All right, so the challenge with this problem is that when we look at where the 62 is located, we're trying to figure out how it relates down to the intersection down at the bottom because of this extra segment EC. So here's how I want you to visualize the impact the 62 has. So what I'm going to do is already the label, everything is labeled from what the drawing gave us. So what we're going to do now is I'm going to bring out a pink marker here, and I'm simply going to highlight the parallel line AB, and I'm even extending it a little bit. The 62 then connects to the other intersections via BC. So I'm going to draw that. And notice that it touches my other parallel line. Remember, every one of these relationships involves two parallel lines and a transversal. So if you simply just look at the pink only and nothing else, what we will see here is that this 62 right here that we had originally is going to be an alternate interior angle with the combination of these two littler angles down below. So together, both of these are going to add up to 62. Because of that situation, that now gives us the power to find angle ECD. What we're going to do is take 62 away from 36 away from 62, leaving us with 26. So if I take away all that extra writing that we just did, okay, we now know that this angle right here has to be 26 degrees. So again, just as a summary, these two angles make an alternate interior angle with the 62 up here. Now we're going to use this same idea to find our final angle, which is angle CEF located right here. So once again, what we see here is a parallel line and then a transversal that connects to another parallel line. Now, if it helps sometimes, I'm going to just extend these segments a little bit, because when I do, you can kind of see that same transversal parallel relationship. This 26 right here and this angle together, by definition, if we look at just the pink here, those are considered same side interior angles. And therefore, to figure out this last angle right here, we would just do 180 minus 26, giving me my final answer here. And we'll clear this all out. That final answer being 154. Remember, the goal in these problems is to eliminate unnecessary information and highlight the important information. Using a bright color like a pink or a red color on top of your markings can help you eliminate the noise in these types of problems. Now in this problem, what we have here is the parallel lines marked in green, the 32 and the 89, which were given to me in black, and the two angles that I want are both in blue. Now the issue here with the angles in blue is that we're using the transversal DG, and DG and DB are different transversals. So we have to almost separate these problems and look at them apart from each other. For example, using the pink here, we see that the 32 is made up of this parallel line in pink, and then this parallel line down below will also connect them together. And when you look at just the information here in the pink, we'll see that the 32 and then this top angle, which is BDE, those two together are going to give me 32. Those are alternate interior angles. That is a different relationship. So when we remove all of that extra stuff, that is a completely different relationship than what we see down here with this parallel line, and the transversal seen here. Completely different transversal, so we have to separate the two. But now the good news is, if we know this angle was 32 from here to here, and the total angle together is 89, what we can then decide here to do to find that first blue angle is 89 minus 32, which tells me my first answer here, angle EDG, must be 57 degrees, since they both would add to 89. Using the pink parallel relationship that you see here now, what we can look at is that here's our parallel line, and transversal. We can see that the 57 and this angle here are going to be same side interior with each other, which means that they are going to add up to 180. 180, 57 subtracted from 180 is going to give me 123 degrees. And so for this problem, we got EDG as 57 degrees and DGH as 123 degrees. When working with complex diagrams, as we see here, it's really important to focus only on two parallel lines and one transversal at a time. So the angle that we're looking for here is CBF marked in blue. But notice that that is on a completely different transversal than the 42. The 42 is using this transversal EC, and the one that we're trying to find is long transversal AC. So let's figure out where they're connecting down here, because that's going to be my entryway to move from one transversal to the other. So let's focus on the 42 first. So as mentioned, the transversal here is EC. The lines are going to be located here. Let's redo that, because 1 and 2. And what we should hopefully see by just looking at the information in pink only is that 42 and this angle right here will also be 42, because these two angles are considered corresponding to one another. So let's fill that in, and that's going to be an important entryway into the next stage of this problem, because if this angle is 42, based on the definition of bisect as given in the diagram, that means that this angle BCG is also 42 degrees. Just remember, that means collectively that angle BCD together is 84. That's going to be important because now we have a number that we can use on our next transversal. So the transversal AC, the parallel line BF, and I'll extend it out a little bit, and the parallel line CD. When we look at all that information there, once again in pink, we see that this entire angle connecting the transversal to the parallel line is going to be 84 degrees. Therefore, the blue angle that we're trying to look for is going to be a same side interior angle to it, based on being the same side of the transversal and in between the parallel lines. That means they're supplementary with each other. So 84 subtracted from 180 is going to give me 96 degrees, which is what I'm trying to look for in this problem.